This video demonstrates the functionality of the file system filter driver on the Macintosh platform. The file system filter driver could be used for various features like DLP or archiving or any other feature which can make use of the file system filter driver functionality. The first important point is the file system filter driver can be installed or removed without disrupting the existing file system I/O. So that enables installing or removing this driver in the customer environment without affecting their existing setup. And it is very important from customer point of view. Second is the file system filter driver sits between VFS layer and the file system, and it interacts with the VFS and the file system layer to intercept all the vnode operations. It can intercept any vnode operations like open, close, read, write, mmap, page in, page out, unlink, and so on. Third, the file system filter driver uses first 1K bytes in the file to store any Commvault specific metadata. So the metadata could be specific to the functionality, meaning if it is a DLP functionality, then the metadata represents how the file is encrypted and how to decrypt it. If it is archiving feature, then the metadata reflects how to retrieve the file when it is accessed by a process. Now, since the metadata is stored on the first 1K block, the driver has to access first 1K block to decide whether to intercept the vnode ops or not, and that could potentially slow down the operations. Hence, to mitigate this fact, the file system maintains the cache of metadata, and thus it tries to improve the performance. So here, let me first load the driver. So as you can see, the file system filter driver is loaded now. Now I'm going to start the DLP service. So DLPD is mainly a test utility, and it has features to demonstrate the driver functionality, as well as it has various unit test features. So if you press Ctrl C, it shows various options, and these options are encrypt the file, monitor the file vnode ops, check if the file is in use, trace file vnode ops using inode number, check if a file has a metadata, then control the behavior of the daemon on demand, meaning uh, when the encrypted file is accessed by a process, do you want the file to be decrypted or not? And then others are stopping the service. So first, let me quickly demonstrate the encrypt and decrypt functionality. So I'm going to use this file to encrypt first. So let me open the file first. It's a PDF file, and it's fairly short. I think maybe a few hundred K. So let me first close the file. Okay, so I'm selecting option 1, and now we are going to encrypt the file .pdf. So now the file is encrypted, as you can see on the screen, and you see a couple of vnode op events on various files. The first event is inactive. It says file is not in use by anybody, and at that moment, and this event is on a different temporary file created during encryption process. Now, if you open this file again, the file system driver will intercept the read, write, mmap, and so those events, and let the test utility know about the file access, and that the test utility then acts on those events. In this case, it will decrypt the file and then let the driver know about the operation is complete. Till that point, the file system I/O is on hold. So let me open the file. So now the file is getting decrypted, and as you can see now, file is already decrypted. So let me go back to the test utility screen. So here you can see it receives a map event from process called preview, which is related to the Acrobat reader, and then it decrypts the file. So we have other options, like we can monitor a file, or we can check if the file is in use. The file is in use is very important because you do not want to encrypt a file if it is in use by some other process. Next option 6 is also very interesting. Let's say if some process does not want to decrypt the file when it is accessed, uh, then it is also possible. So I'm going to use option 6. So it's saying that don't decrypt the file. Uh, Now let's encrypt the file and see what happens when we access the file. I'm going to encrypt the file again, same file. So now file is encrypted, and earlier we chose that do not decrypt the file if it is accessed by some process. So now let's open the file in VI so that we can see each byte. So as you can see, the file is encrypted. It has a Combalt signature, and there is some DLP specific metadata, and file is not decrypted. So we can verify the metadata from here as well. So it says metadata found on this file, meaning file is in encrypted state. Now let me go back and go back to option 6 and say decrypt the file when it is accessed. So now if we open the file, it will be decrypted by the utility, right? So other interesting feature which is very useful while debugging is you can trace the file while it is accessed. So let's say I have a file called I think FSF something FSF VFS.c, and we will trace the file. So I'm using option 2 to trace the file. So it says whether you want to make tracing on or off. So in this case it is on. Now let's say I view the file using less command. So now you should see various read events, and once the file is closed, you will see inactive event. So this is a very good feature to unit test the driver. And so you can do the tracing using inode number as well. And so these things demonstrate the basic encrypt decrypt functionality. Now let me come out of the utility. So option 7, it says stop the utility. Now going back to the driver statistics. So these statistics represent the cache of metadata we spoke earlier. So there were 620 miss, and look at hit ratio. So we use LRU algorithm. So the cache hit ratio is very high. And look at the VNode-op stats. It says it intercepted 16 read operations, 2 mmap operations, and 19 VNode-op inact operation. At this moment, we are just intercepting read, write, exchange, mmap, and inact. The other VNode-op intercepting is not required at this point, and the functionality is there, and we can enable it if it is required. Okay, so this concludes my demo. If you have any questions, feel free to send me an email. Thank you.